In this video, we'll understand one of the biggest security risks in generative AI, prompt injection attacks. We'll see how attackers trick large language models using plain language, why this is so difficult to fully solve, how it differs from jailbreaking, and what risks and defenses matter in the real world. Let's break it down step by step. A prompt injection attack is a cyber attack against large language models. The attacker hides malicious instructions inside what appears to be a normal user prompt. If the model follows those instructions, it may ignore safety rules, reveal sensitive information, or perform actions it was not supposed to do. This becomes especially dangerous when an AI system is connected to tools, files, emails, or APIs. In that case, a prompt injection is not just about getting a strange answer. It can lead to real-world consequences like forwarding documents, exposing customer data, or carrying out harmful automated actions. The core issue is that LLM apps often combine developer instructions and user input into one natural language prompt. Since both are just text, the model does not have a strong built-in way to tell which part is a trusted instruction and which part is untrusted input. That makes carefully crafted attacks surprisingly effective. Now, let us look at this in a simple table format. Prompt injection vs jailbreaking. Two related but different LLM attack techniques. Prompt injection and jailbreaking are often confused, but they are not the same thing. Prompt injection is about disguising malicious instructions as normal input. Jailbreaking is about making the model ignore its safety safeguards. They can support each other, but conceptually they are different attacks. Many apps use a system prompt to tell the model what role to play and how to respond. Then the user's message is added to that prompt, and the whole thing is sent to the model together. If the attacker writes input that looks like a higher priority instruction, the model may follow the attacker instead of the developer. Now that we've covered core concepts, let's test what we've learned so far. Here's quiz number 1. See if you can get it right. Question 1. What is the main idea behind a prompt injection attack? The correct answer is disguising malicious instructions as normal input. Prompt injection works by making harmful instructions appear like legitimate user input, so the model may follow them. Question 2. Why are LLM apps especially vulnerable to prompt injection? The correct answer is system prompts and user inputs are both plain text. Because both trusted instructions and user input are natural language text, the model may struggle to separate them reliably. Question 3. Which statement best describes jailbreaking? The correct answer is it forces the model to ignore safeguards. Jailbreaking is about bypassing or disabling the model's safety restrictions. In a direct prompt injection, the attacker types the malicious instruction directly into the system. For example, instead of giving text to translate, they might say, "Ignore previous directions," and output this exact phrase. If the model obeys, the attack succeeds immediately. Indirect prompt injection is more subtle. The attacker hides instructions inside content the model later reads, such as a web page, forum post, document, or even an image. Then, when a user asks the AI to summarize or analyze that content, the hidden prompt influences the result. The risks are serious. Attackers may extract the system prompt, steal sensitive data, spread misinformation, or even trigger code execution if the AI is connected to powerful tools. In advanced cases, a malicious prompt can spread through AI assistants by getting forwarded from one user or contact to another. Preventing prompt injection is difficult because the attack exploits a basic strength of LLMs, responding flexibly to human language. Strictly limiting inputs can reduce usefulness, but loose controls increase risk. Even AI-based detectors and rule-based filters can miss new attacks or wrongly block safe inputs. Now that we've covered attack types, let's test what we've learned so far. Here's quiz number 2. See if you can get it right. Question 1. What makes a prompt injection direct? The correct answer is the attacker sends the malicious prompt directly as input. A direct injection means the attacker personally enters the harmful instruction into the app. Question 2. Which is an example of indirect prompt injection? The correct answer is hiding instructions on a web page. The AI later summarizes. Indirect injection happens when the malicious instruction is planted in outside content the model consumes. Question 3. Which of the following is listed as a major risk of prompt injection? The correct answer is data theft. Prompt injection can trick AI systems into exposing private or sensitive information. While there is no complete fix, organizations can still reduce risk. Good security practices help users avoid malicious content. Input validation can catch some known attack patterns. And most importantly, AI systems should be given the minimum permissions needed, so even if an attack works, the damage stays limited. The big lesson is this: with LLMs, plain language itself can become the attack vector. Because the boundary between trusted instructions and user input is blurry, security cannot rely on one safeguard alone. Layered defenses, careful tool access, and constant testing are essential. Now that we've covered defense ideas, let's test what we've learned so far. Here's quiz number 3. See if you can get it right. Question 1. Why is prompt injection hard to eliminate completely? The correct answer is the attack exploits how LLMs process natural language. Prompt injection takes advantage of a fundamental part of LLM behavior, following text instructions in natural language. Question 2. Which mitigation step is mentioned in the article? The correct answer is input validation. Input validation can help detect and block some suspicious prompts, though it is not perfect. Question 3. What is a smart design principle for AI tools connected to actions or data? The correct answer is reduce permissions to what is necessary. Least privilege access helps limit harm if a prompt injection succeeds. That's it for this lesson. If you understood how prompt injection works, why it is dangerous, and how to think about mitigation, you've covered a very important concept in AI security. Keep learning, keep questioning model behavior, and most importantly, design AI systems with security in mind from the start.